Hey guys, so I thought I would try this again on paper, see how it goes. Here are the answers to the Chapter 9 Homework Number 6 review. Check them out. Oops. There's 8 through 10. All right, let's try and work through the problems. So, looking at number 1, I'm supposed to write a rule for a translation. So I know I'm going to be doing a translation, and I know I'm going to need a vector for that translation. And I am going to be translating triangle PQR. So the important thing is to figure out the vector. And the way you figure out the vector is by using point P and point P prime. Not only does this vector tell you how to move the triangle, like left or right, up or down, but the two coordinates also tell you, in addition to that, how the x-coordinate of each point is affected and how the y-coordinate of each point is affected. So I see that when point P moved to point P prime, the x-coordinate went from 4 to -1, or down 5, which means the x-coordinate of the vector is -5. And the y-coordinate went from 3 to 6, which means the y-coordinate went up 3. And therefore, my vector is -5, 3, and I have the rule for this translation. Then I can take point Q and I can do the rule, the vector, to it. When I take 7 and go down 5, that would take me to 2. And when I take 3 and go up 3, that would take me to 6. And then I would take point R and I would apply the vector to it. When I start at 6 and I go down 5, I end up at 1. And when I start at 8 and go up 3, I end up at 11. And there are my answers to the first problem. Number 2. Number 2 wants me to use this rule to do a translation. So this is what we call coordinate notation instead of vector notation. But it means the same thing. The x value goes up 3, or in vector notation that would look like that. And the y value goes down 1, or in vector notation it would just be a -1 there. So I need to take this triangle over here, and I need to move it 3 to the right and down 1. So I'll start with point D, and I'll go 3 to the right and down 1. And point E will go 3 to the right and down 1. And F will go 3 to the right and down 1. And I have D prime, E prime, F prime. Let me go ahead and connect those. And there is my translated triangle. Now, I was also supposed to use arrow notation to describe the image of each vertex. I had already done D for you. E went from negative 2, 5 to E prime, which is at 1, 4. F, which started here at 1, negative 1, point F, it went to F prime, which is at 1, 2, 3, 4, negative 2. And I'm done with that one. Figure 3 is a translation. Figure 2 is a translation of Figure 1. I'm supposed to write a rule. So translation, vector, maybe triangle 1. And the real key is, what's my vector? So I'm going to take this point, and it went here. That would be 1 to the right and down 4. So positive 1, negative 4. That was an easy one. That takes us to number 4. Again, I'm supposed to write a rule that uses a translation. So I'm going to have a capital T for translation, and I'm going to have a vector. And this is going to be of triangle ABC. And I just need to know my vector. I'll do point C, which goes from here to here. So here to here, that would be 1, 2, 3, 4, 5, left 5, and then up 3, so positive 3. Number 5. All right, number 5 is a tricky one because I have given you the coordinates of the image. And I have asked you for the coordinates of the pre-image. So it's like I'm working backwards. Now, if you remember from number 1, the vector is what happens to the x-coordinate and the y-coordinate in a translation. If we just look at point P here, right? Point P is going to be some ordered pair. And I need the x value to be a number that when I use the vector positive 3, I end up at negative 2, right? I need an x value so that when I go plus 3 to it, I end up at negative 2. The pre-image is some x-coordinate, and then when you add 3 using the vector, you end up at negative 2. Well, that would be negative 5. The x-coordinate needs to be negative 5. And I need a y-coordinate for this point P, which is, of course, this is the pre-image. And the y-coordinate needs to go, as it says here in the vector, it needs to go down 7. And I need to end up at 7. So some y-coordinate minus 7 needs to end me up at 7. What's the pre-image so that when I go down 7, I end up at 7? That would have to be 14, right? Then I would do the same thing to Q. I know what Q prime is. I don't know what Q started as. But since the vector says add 3 and you end up at 1, I need some number that when you add 3 you get 1. That means the pre-image must have been negative 2. And I need a y-coordinate that when I subtract 7, I end up at 5. Some number minus 7 needs to give me 5. That would be 12. And then I'm ready to do the r coordinate. So the original r value would be an ordered pair. And again, the vector says add 3, and you end up at 4. Gosh, what number can you add 3 to? Start at some number, add 3, and get 4? That would be 1. And the vector says the y-coordinate goes minus 7. I need to start at some number, subtract 7, and end up at negative 11. So that might be, let's see, some number minus 7 equals negative 11. I could write it like that to figure it out. That would be negative 4. And now I have the 3 coordinates of the pre-image, and we're ready to move on. Number 6. So number 6 says I have the vertices, and I want to find the coordinates of these points when I reflect across the y-axis. So since this is the y-axis, I think we can do it without a graph. But over here I'll do a little sketch. So look at point A. Point A is at negative 5, 4. Like right there. And point A is going to go across the y-axis. So it's going to go this way and end up over here. Notice how the y value does not change. It just goes 5 spots to get to the y-axis and then 5 spots to the other side, but the y value is still 4, like it was here when I started. So let's see, 5 spots to here, 5 spots to here would put me at 5, 4. This is going to be 5, 4. And in fact, I don't know if you can tell this or not, but when you go across the y-axis, the only thing that changes is the x value changes sign. Let's try that one more time. How about the b value, which is at negative 2, 4? So it would be like right here. It would go 2 spots to the y-axis, 2 spots to the other side, and it would end up there. Again, it's still going to be at y equals 4, but now the x value is 2. It's the ordered pair 2, 4. And last up, we have negative 4, 2. That's like right there. So 4 spots to the y-axis, 4 spots to the other side, and I would be like right there. And that would be the ordered pair 4, 2. And we're done with that one. Number 7 says use arrow notation to describe the image of each vertex. It's a reflection across the line x equals 0. Well, x equals 0 is the equation for the y-axis. So let's draw the line of reflection here, and let's reflect each point across it. X would go 2 spots to it and 2 spots to the other side. Y would go 2 spots to it and 2 spots to the other side. And Z would go 1, 2, 3, 4 spots, 1, 2, 3, 4 spots to the other side. And my triangle would look like this. And if I name the ordered pairs, I see X is already done. The Y started at negative 2, 1. And it ended at positive 2, 1. The Z started at 1, 2, 3, 4, negative 4, 1. And the Z ended at positive 4, 1. And that problem is done. Next up, we want to graph the reflection across the line y equals negative 2. So y equals negative 2 is a horizontal line right here at negative 2 on the y-axis. So I'm just going to simply take each point and reflect it across that line. A would go down 1. Oops, you can't see that. Down 1 and then down 1 again, and A prime would end up here. B would go up 2 and up 2 again and end up here. And C would go up 2, and so up 2 again, and would end up here. And my triangle kind of flips over, doesn't it? So then I need the coordinates of each of those points. B is at 0, 0. C prime is at 1, 2, 3, 4, 0. And the A prime is at positive 2, negative 3. Is that right? 1, 2, 1, 2, 3. Yep. Positive 2, negative 3. The next reflection I'm doing is a reflection across the line x equals negative 1. So let's draw a line at x equals negative 1. That would be right here. Okay. And let's go ahead and graph each point across that line. A is 1 to the line and 1 to the other side. And we have A prime. B is 1, 2, 3, 4. 1, 2, 3, 4. B ends up right here. And C is 1, 2, 3, 4. 1, 2, 3, 4. C ends up right here. Let me go ahead and reconnect that and shade it in. And I'm supposed to name the coordinates. So A prime would be at negative 2, 1. B prime would be at 1, 2, 3, 4, 5, negative 5, 1. And C prime would be at negative 5, 3. And I have named the coordinates. Number 10, name the reflection rule. So since it's a reflection, I'm going to have a capital R, and I'm going to be reflecting triangle ABC. I just need the line. And let's see, the line would be here between B and B prime. That's 1, 2, 3, 4 spots, so I'll go 2 spots. And this would be my line. That is going to be the line x equals, and it's 1, right? X equals 1, since it's a vertical line. Number 11 is also name the reflection rule. So again, because it's a reflection, I'm going to have a capital R. And the thing I'm reflecting is triangle XYZ. And I just need to find the line of reflection. So I'm going to find 2 points that correspond, like y and y prime. And I'm going to see how far apart they are. 1, 2, 3, 4. So I'm going to go halfway, which would be 2, and make my line there. So that would be this line. That's not a very good line, but there you go. A horizontal line. It's going to be y equals, because it's horizontal, and it's at negative 2. It's going to be y equals negative 2. And there's my reflection rule. Number 12. The vertices of triangle LMN are this. And I want to find the coordinates for the reflection across the line x equals 1. So if I was having trouble with this, and I couldn't do it without the graph, I'd probably go to one of these graphs up here, and I'd graph it. Like L is at 2, negative 3. So I might go to 2, negative 3. And that green dot is L. I guess I'll put an L there. And then M is at 2, 2. So that's right there. All right. Kind of out of focus for a second. And last up I have N at 5, 2. 1, 2, 3, 4, 5, 1, 2. N would be here. And I want to reflect those 3 green points across the line x equals 1. So x equals 1 is this line. So that doesn't look too bad. I don't have to graph this. I'm really just using the graph so I can name the ordered pairs here. I noticed that L would end up right here, and that on this graph is the point 0, negative 3. There we go. M would end up, let's see, 1 to the line, 1 to the other side. That would be right here, which is the point 0, 2. And N would be 1, 2, 3, 4 spots to the line, 1, 2, 3, 4 spots to the other side. It ends up right here, and that's the point -1, -3, +2. And I have the coordinates of the reflection. Number 13, I have a rotation. So the rotation is probably the hardest, but you know, every time we do a rotation, pretty much, we do it 90 or 180 or 270. And you can tell how far it went by how many quadrants it went. This rotation went from quadrant 1 on the graph to quadrant 2. So it only went one quadrant. It's probably a rotation of 90 degrees. And of course it's going around the origin. And that's triangle PQR. Again, I say 90 degrees because it went one quadrant. Two quadrants would take me 180 degrees, and three quadrants 270 degrees. I could always check that by checking one of the points to see if it is 90 degrees, but I think that rule's a pretty good rule for you right now. Let's go to number 14. There we go. So 14 wants me to do a rotation of 270 degrees. So I'm going to rotate this 270 degrees in this direction. So I'm turning my paper the direction of the arrow. So that would be a 90-degree rotation. Then that would be 180 degrees. And if I go one more time, I have now gone 270 degrees, and I'm ready to name my coordinates. So x here now has x prime at +3, -2. Y now has y prime at +1, -2. And the z-coordinate, when I rotate it 270 degrees, is now at +1, 1, 2, 3, 4, 5, -5. Let's go ahead and rotate it back. And I guess I'm going to graph those first. So over here I can see that x prime is at 3, -2. And y prime is at 1, -2. And z prime is at 1, -5. And I can go ahead and reconnect that and maybe shade it in. And then I can go ahead and name the pre-image ordered pairs and the image ordered pairs. So x started at 2, 3, and ended at 3, -2. Y started at 2, 1, and ended at 1, -2. And z started at 5, 1, and ended at 1, -5. There we go. Number 15. I'm supposed to rotate this rectangle 90 degrees. So 90 degrees would be this direction. I'm going to turn my paper 90 degrees. And I'm going to see where the rectangle ends up. And I see that it ends up with A prime. Let's see if I can help you see this. No, not really. All right, so A prime ends up at -3, +2. All right? And B prime ends up at 0, 2 after the rotation. And C prime ends up at 0, 4. And D prime ends up at -3, +4. So let's go ahead and rotate back. And let's go ahead and put those in the slots they belong, -3, 2. And B prime is 0, 2. And C prime is 0, 4. And D prime is -3, 4. And I was supposed to graph them, so A prime, -3, 2. B prime is 0, 2. C prime is 0, 4. Oops. And D prime is -3, 4. And my rectangle looks like that. All right, number 16. If the point P is rotated 180 degrees about the origin, and you end up at P prime, find P prime if P is -3, 5. So again, I didn't give you a graph for this one, but maybe I go use a graph. Maybe I'll just go ahead and use this one again. And I will say, let's see, -3, 5. 1, 2, 3, 1, 2, 3, 4, 5. -3, 5 is right here, right? Green point right here. So I want to do a 180-degree rotation and figure out where P prime would be. So 180 degrees is this way, 2 turns. There's 90 degrees. There's 180 degrees. And my green point ended up, after a 180-degree rotation, at 1, 2, 3, 1, 2, 3, 4, 5, 3, -5. So let's turn back, and we can say that P prime is at 3, -5. All right, I had this one that's a little more challenging. I'm doing a 90-degree rotation, but I'm rotating around the point 2, 1. So I'm going to go ahead and put a green dot at 2, 1. That's this point right here. This is my center of rotation. So if you remember this from the day before, the way to do this is to make a new and pretend X and Y axis where that is the center of the X and Y axis. So I'm making a new one. And I'm going to use this X and Y axis, the new one, to do my rotation so that I rotate around this point. But then, after I graph the rotation around this point, I'll go back to the regular X and Y axis and I will name where the triangle ended up. So, this is a 90-degree rotation. Let's go ahead and rotate it 90 degrees. Remember, that's this direction. So, one turn. And I notice that A ends up at 1, 2, 3, 4, -4, +2. So let's make that A prime is -4, 2. There we go. And then B prime, according to my new center, is at -1, 2. And C prime is at -1, 1, 2, 3, 4, -1, 4. All right, let's rotate back and let's graph that triangle. Again, I'm going around the fake X and Y axis here. So A ends up at -4, 2. That would be 1, 2, 3, 4, 1, 2. A ends up here, A prime. B ends up at negative 1, 2. So negative 1, 2 would be here. There's B prime. And C ends up at negative 1, 4. Negative 1, 1, 2, 3. I wish I had put the B prime down here. Negative 1, 1, 2, 3, 4. And there is C prime. So my triangle looks like this. And now I can name the actual coordinates of those points. Notice my triangle rotated around the green point, but now I'm going to name its actual coordinates on the actual graph. A prime is at 1, 2, 1, 2, 3, negative 2, 3. B prime here is on the actual graph at 1, 1, 2, 3, 1, 3. And C prime is at 1, 1, 2, 3, 4, 5, 1, 5. If you're getting that one, you're doing awesome. All right, the rotation rule. Since I know this is a rotation rule, I'm going to write rotate, and I'm going to put my parentheses, and we're always going to go around the origin. And this is going to be triangle ABC. And again, from what I told you before, this one went from quadrant 1 down to quadrant 3. So it went 1 quadrant, 2 quadrants. Every time it goes a quadrant, it's 90 degrees. So it's 90, 180. This would be a 180 degree rotation around the origin. Let's move on. Almost done. All right, number 19. So here's the thing to think about in number 19. When you have a circle, or when you have a point, and it rotates all the way around back to where it started, that is 360 degrees. So, here's how that helps you with all three of these problems. Let's start with the 90 degree rotation. So I claim that if you had a point and it rotated 90 degrees, it would end up right here. But if it rotated 90 degrees and then another 360 degrees, it would end up right here also. 90 degrees would be exactly the same rotation as 90 plus another 360. So that's where I got the 450 degrees being the same as 90. And you know what? If I added 360 again, it would be the same rotation again. So if I took 450 and I added another 360 to it, I'd still be in the same place. And that would be a 810 degree rotation. So you can take the 90 degree rotation and you can add 360 as many times as you want, and you end up in the same place, or you have the same rotation. You could also subtract 360. I'll do that on the next one. So if I had a 180 degree rotation, that might take you from like here down to here, 180 degrees. And then you added another 360 to it, 180 plus 360 would be the same thing as just 180. So that means 180 plus 360 would be 540 degrees, would be the same as just 180. Or watch this one. If I go 180, that would be the same as going negative 180. Or 180 minus 360. That would be negative 180. The bottom line is this. As long as you take 180 and you either add 360 to it or subtract 360, you end up with an equivalent rotation. And the same with 270. If I add 360 to it, I have an equivalent rotation. I end up in the same spot. So that would be 630, I believe. And then if I add 360 again, I'm still in the same spot. So 630 plus another 360 would be 990 degrees, I believe. I hope that's right. I think it is. All right. That takes me to the last problem. All right. So I am supposed to name the type of transformation and write the rule for it. All right, so the easiest one is, well, I don't know. I'm going to start with letter C. Letter C is a reflection, and I think that's fairly obvious. And this is the line of reflection, the y-axis. So I'm supposed to write reflection here, and that would be a capital R, and the line I'm reflecting across is the y-axis. Or you could have written x equals 0. Either one of those would be fine. All right, I want to discuss A. A looks like it could be a reflection across this line. But the reason it's not a reflection is because A does not match up with A prime across that line. A and C match up. That's how you can tell this is not a reflection, but actually it's a rotation. And it's rotating that way 180 degrees. And so when it rotates, it would look like that. So you could actually rotate it and see it would look exactly the same. Notice how the C ended up where the C prime was. So this is a rotation, and it's a rotation of 2 quadrants, so that's 180 degrees around the origin. And then last up in B, I noticed that all of these points just seem to slide the same distance. So that is a translation. And I'll use A to figure out the slide. Oops, A is up here. It's left 1, 2, 3, 4, 5, 6. Left 6, so translation of left 6. And then down 1, 2, 3, 4, 5, 6, down 6. And there's my translation. All right, hope that helps.